So in the last two sessions, saw we were studying about the first two chapters from classical mechanics, theoretical minimum textbook. So first one was the nature of classical physics, and we also saw motion and how to calculate motion using calculus. So now we'll be talking about dynamics. Dynamics. So basically, this deals with the dynamics of particles. So not just motion, but more than just motion. So now, uh, what makes things to stop moving? What are the things that don't move? So first we look at Aristotle's first laws of motion. Aristotle's laws of motion. Aristotle was a pioneer of a lot of subjects from philosophy to motion, but his idea on motion were quite remarkable, and they did serve as some of the core concepts for several centuries. Now, it has the it had a big flaw in it, and but still, it's important because it at least discussed about the topic. So what does the law state? So basically, it says that the velocity of any object is proportional to the total applied force. So basically, he means F equals mv, which is actually, as we know now, is wrong. So it does not very much up. And so one thing that he did not know was the concept of friction, and which is why after Aristotle, the next revolutionary idea in this same field was brought about by Newton. So Newton just said force equals mass times acceleration. So force equals mass times the rate of change of velocity, not just the force. So what he said was uh, enter Newton. Newton's laws of motion. So now he said force basically equals m times v dot rate of change of velocity, which means it's just acceleration. So his first law states that Newton's laws of motion. Now his first law states that an object at rest stays at rest unless it is acted upon by some external force. So which means that an object at rest or in motion. So an object could be moving with same velocity, or it could be having zero velocity. Either way, unless it has any acceleration, it keeps going that way. So that is his first law of motion, so called as law of inertia. So the inertia is the main topic he discussed in his first law. In second law, basically says that force. So that's the equation. F equals ma. The force applied is directly proportional to the mass times acceleration, which is just the rate of change of velocity. Now he also said that the the equation was somewhat more like the actual thing, but probably was like force by m, something like that. But either way, we make it more useful by putting it like this. His third law was that any object that applies force. Let's just go to Wikipedia to be exact. So, to every action, there's always an opposed and equal reaction, or the mutual actions of two bodies upon each other are always equal, directed in contrary parts, which means that, say, you push upon a wall. I mean, you can basically express it like this. So, if you push upon a wall, the wall exerts equal and opposite force, and if one equals if two, then this, so the wall exerts equal amount of force just in the opposite direction. So to know that the direction should be the opposite. So you can say maybe like minus f1 like that. So uh, just minus does not mean it. So yeah. So uh, that's the Newton's third law, and that basically says everything about the dynamics. So it's pretty short chapter, we can say. So these are just the concrete topics in the kinetic physics, and yeah, I mean, the uh, as I said, the whole idea of the book is to get an idea on physics. So it's just theoretical minimum, and that's what you just did, and that completes the third chapter on dynamics.